Hi everyone, welcome to class 11 physics. We are studying chapter 2, that is units and measurements. In that our today's topic will be significant figures. Also, we will see what are the rules for determining the number of significant figure in any kind of measurement. Right? Significant figures are related with the digits. Okay. Now you know that accuracy of every measurement has some limitation. That limitation is depending on the least count of the instrument that we are using, right? So there is a limitation of the least measurement that you can do with any kind of instrument. Like if you are using centimeter scale, right, the most common scale that we are using, that is showing the minimum division, that is millimeter. Okay, but if there is any kind of uncertainty in millimeters, we cannot do the exact measurement. That is, we will round it up, or we will approximate the value, or we will estimate the value, right? So significant figures definition, if we see, significant figures are those digits in a measured quantity about which we are certain or we are sure, plus one additional digit which is uncertain. So in any kind of measurements, what we will do, we will estimate or round off in that manner in which the certain or sure digits are also taken along with one additional uncertain digit, right? So it is all about estimating the measurement. Okay. Now let us see an example. Okay. Now here you see a scale, and below that scale you see a red line. Alright, now to be very precise, you see over here, if we start from 0, this is zero point 0.1, zero point 0.2, and here we are completing 1 full centimeter. The next division will be 1.1, the next will be 1.2, then 1.3, then 1.4, 1.5, 1.6. It is perfect. Now this red line is almost in between 1.6 and 1.7. So we can say that the measurement is neither 1.6 nor 1.7 exact, right? It is like it is somewhat more than 1.6 but somewhat less than 1.7. Now this scale has the limitation to measure only up to either 1.6 or 1.7. Now here the red line is in between this 1.6 and 1.7. So now what to do? What next, right? So what we will do, we will round off this measurement by adding one more digit, right? So we will not write it as 1.6 or 1.7, because if you write 1.6, someone will say that no, it is not 1.6, it is little bit more than 1.6. Okay, or if you will write 1.7, then another person will say no, it is not exactly 1.7, it is little bit less than 1.7, right? So what to do in this case? So what we do, we round it off, we estimate, we assume, we guess that if it is in between, it might be 1.65. Okay, so here you see in this it was 1.6, so two digits were there. Over here it was 1.7, two digits. But here what we are doing is, apart from the two digit, we are adding one digit, this one. You see carefully. Okay, so that is why we are interested in number of digits. Significant figures are nothing but they are important digits that are taken care of in any kind of measurement, right? So you can see 1 and 6 we are sure that it is perfect, but 5 we are not sure. So we can say that 1.65 are those significant digits which contain two sure digits, certain digits, and one uncertain digits. Clear? So this is about rounding off, but by very accuracy we are doing. Okay. Now if you have understood this example, let us go for the rules one by one. Okay. There are 5 to 6 rules, and on the basis of each rule I have given two examples, right? Remember one point only, that in all the examples, in all the rule, what we are taking care of is the digits. Clear? Now starting with the very first rule, that is very easy. All non-zero digits are significant. Okay, non-zero digits. So we are taking two different measurement like 12.2 kilogram. So here 1, 2 and 2. These three are non-zero. So we can say that is this measurement contains three significant digits. In the next example, 13.54, 13.54. You see all are non-zero, and that is why we can say that there are four significant digits. Clear? So all non-zero digits are significant. Next rule. All zeros between the two non-zero digits are significant. You see, two non-zero digits in between the zeros, they are significant, they are important, they must be counted. That is why you see here the example is 125.001, right? So here between 5 and 1 there are two digits, they are zeros. Both the zeros will be considered as significant. So in total 1 2 3 4 5 6 all are significant digits, 6 significant. In the next example, you see 100.01, 100.01. So at the starting also there is a non-zero 1, and at the end also there is non-zero. So in between there are three zeros. So all the zeros are significant. So 1, 2, 3, 4, 5 significant digits are there. So all the zeros between two non-zero digits are significant. Next is in a number without decimal point. Right, in a number without decimal point, the zeros to last non-zero digits is considered not significant, right? So you see there is no decimal point in both the examples, right? And at the end we have zeros as well. So you see 13200, 13,200 seconds. Suppose there is a measurement of time, 13,200 seconds. But first condition, it is a number without decimal point. Second condition, the zeros which are at the last, the zeros which are towards the right of the first non-zero digit, right? So last two zeros will be not significant, so they will not be counted. So 1, 3 and 2, only three significant figures are there. Also in the next 860 miles, again a number without decimal point. So last zero will not be counted, only two significant figures. Clear? Okay. Moving on to the fourth one. Here you have to see very carefully, understand it well. Okay. If the number is less than 1, that means 0 point something every time. Okay. The zeros on the right of decimal point but to the left of first non-zero digit. Two conditions have to be satisfied. First of all, the zeros on the right of decimal point but to the left of first non-zero digits are not significant. So you see here 0.00158. So first of all, the condition that it is less than 1. Then decimal point you see on the right side, two zeros are there. Okay, and here then the first non-zero digit starts. So all the non-zero digits will be considered significant, but the zeros which are here over here to the right of decimal, they are not significant. Okay, so 0.00158 has only three significant digits. Another example, if you see electricity 0.001 ampere, only one non-zero digit is there. Apart from that, all the zeros after decimal will be not significant, right? So this rule is perfectly clear with the example, right? Now moving on to the last rule, the trailing zeros. Trailing means those who come afterwards. The trailing zero or zeros in a number with a decimal point are considered significant. Okay, so first condition, the number must be decimal point, and the second condition, whatever zero is after, included after any digit in a decimal place, is significant. So here you can see 0.6700. First of all, less than 0, so decimal 0 point something. Then the trailing zeros are after 6 and 7. So they both are considered significant, right? Over here you see 0.0540. This example is very important. You see there is a 0 before also, but as per the fourth number rule, this 0 that is on the left side of 5 is not significant, right? So we won't be counting this one, but the trailing 0 in a decimal number is considered significant. So 5, 4 and 0, all three are significant. Clear? Also, one note is there that if you change the unit of any measurement, change of unit, okay, the number of significant digits will remain the same. For example, there is a measurement of length called 132 meter, right? So how many significant? All the non-zeros, 1, 3 and 2, 3. But the same can be written as 13200 centimeter. So we are changing the unit meter from centimeter or centimeter from meter, right? So if in case zeros are added afterwards, according to the first rule, the number is not without decimal point, right? So only the non-zero numbers are significant. So 132 is significant. Trailing zeros without any decimal point are not significant. So many rules are applied. Overall, you see change in unit, but no change in number of significant digits. In 132 meter, 3 significant digits. In 13200 centimeter, 1, 3 and 2 only are the significant digits. Clear? So these were some rules of determining the number of significant figures. Questions related to significant figures may be asked in objectives. So take care of these rules and you will score perfectly. Now moving on to a topic which you already have learned in the lower classes, but again let us revise that. Those rules are rounding off. Okay, whenever we are uncertain of any measurement, right? So then we did approximate, estimation, rounding off, right? So let us see few rules that we already know, but let us revise it. For example, first rule: if the digit to be dropped, the last one, is more than 5, then preceding digit is increased by 1. Okay, so in length measurement, if there is 10.38, you see the last digit is more than 5. So what we do? We increase 1 in the preceding. So this 8 will become 0 and this 3 will be increased by 1. So 10.4 centimeter. Clear? So this you already knew. Now if the digit to be dropped is less than 5, then preceding digit is left unchanged. So that is clear. We don't need to do anything when the last digit to be dropped is less than 5. Okay, here it was more than 5. So what we did, we increased 1 in the preceding. But if it is less than 5, then all the digits are left unchanged. Clear? Now the question arises, what if any measurement is having exactly 5? Neither more than 5, neither less nor less than 5. So what to do in that case? So in that case we have to see the preceding digit, whether it is odd or whether it is even. Now see, the rule is, if the digit to be dropped is 5, last digit you see in both the examples is 5, then the preceding digit is increased by 1 if it is odd. Okay, you see the last example. Here the last digit was 5, but you see preceding is also an odd number. Okay, so if the conditions are like this, it is odd number, the preceding one is odd, we add 1 preceding, in that we add 1. So 10.55 becomes 10.6. Clear? So this 5 is rounded off to 0 and we are adding 1 in 5 becomes 10.6. Clear? Now if instead of odd it is even, so what we are doing, we are leaving it unchanged. So 10.45, over here preceding digit was even, so what we did, we kept that digit as it is, so that is 10.4. Clear? So these three rules that we already have applied somewhere in mathematics, but again let us revise it. So I hope by the example specifically you are clearing your rules. Next, now these were all things, all rules that we have studied, they were related to the specific numbers. Okay, the one measurement will be there and we are applying the rule. But what if we are doing arithmetic operations with more number of measurements, right? Suppose if we go back here, the length was only one measurement was there, that is 10.38, and then we applied the rule and it became 10.4, right? But what if there are more measurements and we are doing arithmetic operations, addition, subtraction, division, multiplication? So what to do with the result? There might be a confusion. So what we do, we have one rule for addition and subtraction, another rule for multiplication and division. So let us see what is the rule for addition and subtraction. Now this topic will be very easy, no need to cram anything, just you see the example, it will be clear. Now I am speaking the rule. Final result is written to same number of decimal places as that of the original number with minimum decimal places. Right, so you see there are three numbers: 7.21, 12.141 and 0.0028. Now see the decimal digits, how many decimal digits are there over here. After decimal, two digits are there. Okay, over here three decimal digits are there, and over here four decimal digits are there. So out of all three, which one is having minimum decimal place? This one, right? Two decimal. So now we do the addition process: 7.21 plus 12.141 plus 0.0028. The answer is 19.3538, right? The exact measurement is this one. But as per the rule, we will only write the minimum decimal places. Now see, minimum decimal places 7.21. So that was 2. Okay. So now we have to write only two decimal places. So 19.3538 is reduced to 19.35 only. Clear? So only you just remember minimum decimal places. So the answer must also have minimum decimal place. Clear? Very easy. Moving on to multiplication or division. Here almost the same statement, just decimal digits will be replaced by significant figures. Again very easy, you see the example. Now here we are taking an example of multiplication. Suppose the length of anything is any rectangular portion is 2.613, right? You see how many significant figures? All non-zero, so 4 significant digits. The breadth is 1.2 centimeter, that means 1 and 2, 2 significant digits. So there are only two numbers, one is having 4 significant digits, another is having 2, so minimum is 2. Now if you find area, that means you have to multiply these two numbers. Now if you multiply 2.613 with 1.2, you will get 3.1356 square centimeter. If you see carefully, this answer has 5 digits, right? But our rule was to take only minimum significant digits, right? So we need to convert this 3.1356 into a number which is having only two significant digits. So we are taking 3.1 only, right? So in both the rules, over here minimum decimal places in addition subtraction, over here in multiplication division, do the calculation, no doubt, do the calculation, bring your perfect answer, you can use the calculator, but ultimately the final answer must contain the minimum digits or minimum significant figures, right? So there is separate rule for addition and subtraction, that is decimal places, and minimum significant figures in multiplication or division. So that's it for today's session. Thank you.